In this problem, we're looking at the number of alcohol-related deaths in the United States since 1999, and we have here an equation that allows us to sort of model that, and this is based on the Center for Disease Control and Prevention data, i.e. the CDC. So the first question we're asked is to do some interpretation. We're going to find and explain the real-world meaning of D of 0, D of 5, and D of 8. And rather than to have to compute these by hand, we're going to do it in the calculator. But let's first identify what our variables represent so we know what we're plugging in and what we're getting. So the inputs, the T is the years since 1999, or years after 1999. The D of T, once I plug in a year, what I get is thousands of deaths, the number of people who have died in thousands. So I'll just write 1,000 deaths. And so I'm going to come over here to my calculator. I'm going to input the equation. And I'm going to ensure, that, just to show one way of doing it, I'm going to ensure that when I go to second window, that my independent variable is set to ask. And what that will allow me to do is once I open my table, second graph, I can just manually input values, and it will output the corresponding values from the equation. So I hit 0, you can see it processes that and puts out a 19.5. So here are my answers. I have D of 0 equals 19.5. D of 5 is 20. And D of 8 is 21.6. Or 21.26. And these are all thousands of deaths. And these inputs, well, this is the year 1999, since that's T equals 0. Here's 2004, and here is 3 years later, which is 2007. So what are we noticing? Well, we see that the number of alcohol-related deaths is increasing, and now we're going to try to explain, well, is this such a bad thing? Is it increasing at a slower rate, or is it increasing at a faster rate? And that's what we're going to find out next. So we need to find d prime of t. And to find d prime of t, we're going to need to establish what it is that we want to do. We want to find the slope between two pairs so that we're getting an approximation of the instantaneous rate of change at any input value that we specify. Well, we want these 2 points to become infinitely close together, so we're going to let h get closer to 0, and what I get as a result is the limiting slope, which I just abbreviate with lim here. So this is really just a reminder to us that once we have this thing reduced down, we're going to plug in 0 for h when it's possible. Can't do that now, because if we do that now, we'll get 0 in the denominator. T plus 0 minus t is 0, and that's a problem. So I will go ahead and evaluate the first two pieces. Here's my first thing that I'm going to do, my second thing. I'm going to do that on the next page. So we have d of t is equal to 0.04t squared minus 0.1t plus 19.5. And my d of t plus h is just this equation evaluated for basically replacing all t's with t plus h. And I will do that here. And I will also do that here. So what I put in here has to go in here and here, plus 19.5. And so now we're going to go ahead and do our distribution and our foiling. So I'm just going to go ahead and show what this thing foils out to. Remember, you can't just do t squared plus h squared. You've got to do t plus h times t plus h, which is not the same thing as just squaring the individual pieces. So that gives us t squared plus 2th plus h squared. I'm going to distribute my negative 0.1. So I get minus 0.1t, and be careful here, it's got to be minus 0.1h since you're distributing the negative along with it, and then plus 19.5. So lastly, I'll go ahead and distribute 0.04t squared plus 2 times 0.04, which is 0.08th, plus 0.04h squared. There's my distribution taking place. And then the rest, minus 0.1t minus 0.1h plus 19.5. Okay, well, you can go a couple of different ways here. Now we get to plug all this stuff back in. Here's my number 1, here's my number 2, and recall that the goal was just to establish these two pieces of the numerator, simplify it all out before I plug it in so I don't have too much of a mess, and now I can plug things back in. So we want to know the limit of the slope as the distance between the 2 points becomes increasingly small, and it's going to be this whole thing, 0.04t squared plus 0.08th plus 0.04h squared minus 0.1t minus 0.1h, that should be a 0.1, and that should be an h, plus 19.5. And since this thing is so long, I'm going to have to kind of leak down here a little bit, minus d of t, which is 0.04t squared minus 0.1t plus 19.5. And all of this stuff here is going to be over h. I know this is kind of messy, but this is my fraction bar, and this is all over h, because t and negative t cancel each other out. Okay, so now I'm going to cancel the stuff out that I can. I have a positive 0.04t squared, and I'll have a negative 0.04t squared. I have negative 0.1t, and I'll have negative 0.1t. And then I have 19.5, and I'll have negative 19.5. And so what I have left now to deal with is limit as h becomes closer and closer to 0 of, on top, what's left. I have 0.08th, I have plus 0.04h squared, and I have minus 0.1h. All three of these terms have an h in it, which I can now factor out. So I will do that right over here. So I'm going to write down my little reminder that I'm going to have to plug in 0 for h eventually. Factor one out, 0.08t plus 0.04h minus 0.1, and that's over h. So these guys go away. And I'm almost done. 0.08t. So this is the limit as h goes to 0. Get kind of messy here. Try that again. The limiting slope as h goes to 0 of 0.08t plus 0.04h minus 0.1. And so now because I've canceled out the h in the denominator, now I can go ahead and put my little reminder here into effect, and I can replace h with 0. I don't need the limit reminder anymore because now I'm taking care of that. And so my slope function is 0.08t minus 0.1. So what have I just found? I have found, from manipulating a slope, reducing it, simplifying it, canceling it down, I get a slope that's equivalent to this guy right here. Now it happens to be an equation, so this is a slope generating equation. This tells me the slopes at any value of time that I want. Now what I want to find is d prime of 0, d prime of 5, and d prime of 8. So not only do I know already the number of alcohol-related deaths in 1999, 2004, and 2007, but now I'll also know how quickly the number of deaths was, how quickly it was growing each year. So d prime of 0, that just means take my slope function, plug in a time value of 0, and it tells me that at that moment in 1999, my slope was actually decreasing, or the number of deaths was decreasing by 0.1 thousand deaths per year. So that's about 100 deaths per year. Well, everything sounds great, but we actually see that eventually in 2004, the number of deaths actually increases, and now when we find our rate of change in that year, we find out that this is negative 0.4. Oh, sorry, this is an equal sign, not a negative sign. Let me get rid of that negative sign. So positive 0.08 times 5 is 0.4, and 0.4 minus 1 is 0.3, positive 0.3. And that's, again, thousands of deaths per year. If I plug in an 8, I get 0.64 minus 0.1, which is 0.54, 1,000 deaths per year. And so what I notice here is that not only is the number of deaths going up, but it's going up at an alarmingly faster and faster rate. And I believe we've answered all the questions. Back up here for a second. Oh, and lastly, we want to do something that we haven't really looked at necessarily, which is solving a slope equation. So this says solve d prime of t equals 21 and explain the real world meaning. Hint, you are solving for t when the derivative equation outputs 21. Well, what does that mean? When the derivative equation outputs 21, that means this guy is a slope. And I want to know, at what time does a slope like this occur? Now this is thousands of deaths per year. So I'm asking, in what year are there 21,000 deaths per year? Is that rate of change effective? And I will answer that pretty simply because we have our slope function here. So d prime of t equals 0.08 t minus 0.1. And so I want this guy to be 21, 0.08 t minus 0.1, which means 21.1 equals 0.08 t. And when I divide those, 21.1 divided by 0.08, I get 263.75. So t is about, or is equal to 263.75. So what does that mean? Well, this is the number of years after 1999. So 263.75 years after 1999. Well, obviously we can't predict that far out in the future, but it is estimated that deaths will be increasing by 21,000 per year. And of course we mean in terms of just alcohol-related accidents, alcohol-related deaths. So this is of course kind of a little bit bogus because this is not a very good prediction since we don't really know what's going to happen down the line, but this is what it would mean.